Good morning all. The next thing I want to do with my temperature and humidity radio receiver and display project is to do something with the radio receiver. So let's take that off. In fact, I'll do it right now. It'll probably upset the software a bit. That's the power. Yes, this thing here, which at the moment is a bit of prototyping board with wires all crossing over. This intermediate board, which really only has a 3.3 volt regulator on it and some capacitors, and an LED and a resistor, and the appropriate 2x4 connector female socket to take the NRF 24L01 plus transceiver. So I want to make a PCB which has that 2x4 socket for the NRF transceiver, but it munges together, that's not the best word, is it? Mixes together this intermediate board with the regulator on it and a connector down here which has 5 pins. Now these go to D13, 12, 11, 10, 9 and 8. I don't think I need 8. 9 and 10 I think are chip enable and CSN. I can't even remember what CSN is, but those two signals can, I think, go to any pin, but it makes sense to put them on 9 and 8 so that you use a run of 5 pins. So I don't need 6 pins, I think I only need 5, so it's going to be quite a narrow board. I will put a regulator and some capacitors and possibly an LED and resistor on my board. Down here there'll be an option for right angle pins if you want your radio tower to sit vertically, which I quite like. Or of course you could put some pins coming down to the bottom if you want to sit this either into a breadboard or into the Arduino breakout board horizontally. There'd be nothing to stop you doing that. And at the other end, of course, you've got this 2x4 connector, but on this board it's offset to one side. So I think I want to offset it so that my board lines up with this board and make it all kind of neat. Now on this setup, VCC and ground actually come in on a pair of wires from a suitable pick-off point, and I've used the ICSP header on the Nano for that. And I think I'll duplicate that because there really isn't VCC nearby. There's a ground there beyond pin 13, but there's no VCC along this side, so it's going to have to be a wire for VCC. So it might as well be a wire for VCC and ground. So I think I'll go with a 2-pin header to provide power into the regulator, very much as this arrangement. I'll copy that for my PCB. Now I'm going to cover the design process using EasyEDA in some detail. So this is really going to be mostly an EasyEDA design, not so much a tutorial, but just showing the process of knocking this PCB up in EasyEDA. So let's head on over there on my PC now. So here I am in EasyEDA, and I've created a new project which I've called Radio Tower, and in it there's Radio Tower Schematic. Let's just have a look. Oh yes, this is my new t-shirt, JLC PCB and Julian eyelet, although it's quite chilly in here, so I might well put my fleece on in a moment to keep warm, so I'm not sure how much of this new t-shirt you'll see. So this board is essentially 2 connectors, so let's just go to the library for some basic connectors. I want a 5-way single row, and I'm going to go for female even though it's a male connector because it has the slightly smaller holes, so it's a bit of a better fit. I'll go for a 1x5. Then you have to click it and place it. And then the other one I need is a 2x4. Again, I'll go for female. So 2x4, header female. Oh, I need to right click that to get rid of it. And there's my 2x4, and the numbering looks right. Yeah, 1, 2, 3, 4, 5, 6, and 8. So I'll place that. That can go at the other end. So the 2x4, this one here is where the NRF 24L01 plus board plugs in, and this one H1, the 1x5, is going to go into the nano expansion board. Actually, what I'll do is I'll take that one and exit, press X on the keyboard, and that just flips it in the X direction. What's that little? Oh, that's the underscore, yeah. So that's fine. Now in the middle, I need really just the regulator, and on that sort of intermediary board, I'll go back to the camera in a moment, there are 4 capacitors, so I'm going to have 4 capacitors. Yes, on this board we've got the 3.3 volt regulator, 4 capacitors here, 2 big ones and 2 small ones. So I'm probably going to go, I think it's a big one and a small one essentially on the input, and a big one and a small one on the output. There's a resistor 1K and there's a little LED. So I'll probably copy all of that. We need a 2-pin header for power coming in to this board. Now my PCB is going to be this intermediate board to carry the NRF, and also the backboard, which it's all going to be one board, which has my probably normally right angle connector, because I quite like the way the radio tower sits vertically. That makes sense to me. We're going to have this offset thing, of course, because these female 2x4 headers are quite tall. There's no avoiding that really. I just realized that my image was blocking this area here, so if I work at the top here and keep my image down here at the bottom, that should all work out okay. So we need a 2-pin header. Let's change this to 1x2, click on it, and let's rotate that with the R key on my keyboard. Yeah, I can put that at the top for power. Right click to get rid of the floating second one. We don't want a second one. So that's H3, that's fine. Now, I want a regulator. And what I want to do here is I want to have JLC PCB actually fit these surface mount components for me, because I'm not very good with surface mount components. So let's get them to do it, and I think there's a special offer. So let's do that. Let's go to library. This is all a bit slow because OBS is slowing down my PC, but it's not too bad. And we want EasyEDA, symbols, and JLC PCB assembled. So these are the components that they will put on my board for me. I want capacitors, but I think probably the best place to start is with power management, dropout regulators, LDO. Let's try linear voltage regulators. Dropout regulators, how many have they got? Just see how long. Oh, that's a very long list. Linear voltage regulators is not such a long list, but let's just have a look through here and see what there is. I'm just going to widen this out actually. I'll take it out to about there so that I can see the whole width of that. Yes, that's better. Now, is there anything in here which stands out? I really want the 1117 device, because there's an IFX 1117 there. Infineon Technologies. Let's go to dropout regulators and see what we've got in here, because there is a big list of these. And what I really want is basic parts, because I know that they will keep the cost down. So let's just scroll through and see what we've got in basic parts. Not many, it would seem. Those are all extended parts. Oh, they're all extended parts. Okay, let's go back to linear voltage regulators and see if I can find some basic parts. No, they're all extended parts. Okay, no basic parts in voltage regulators. I'll just keep looking for a bit. So I've put in the search string LDO fixed 3.3 V1117, and I've got, they're all extended parts. So I've got this one, LD1117 S33CTR. The help for that says 3.3 volts, fixed, low drop, positive voltage regulator, 17 cents. So that looks pretty good. I think we'll have that. I need to place that on my drawing place. Will that do it? Yeah, so let's put the voltage regulator here. I might move these connectors. I don't want a second one. I might move this because this is my input connector around to here. And this, most of this is passed through actually to the 8-pin connector. So I might put that, let's rotate that, and then I can link the connections up to there, and I'll bring this over, rotate it, and stick it there because that's my input. Okay, next I need capacitors. So here's the data sheet for this ST Microelectronics LD1117 load dropout up to 800 milliamps. That's ample. I'm using the SOT223 version in 3.3 volt. Let's look at the typical application diagram thing. Here it is, schematic application. Now they're saying for other fixed voltages, for 1.2 volts you need a load resistor here, but for other fixed voltages, so the 3.3, just 100N on the input and 10 mic on the output. So let's do that. Once again, I want capacitors from the JLC PCB assembled library. So we go up here to capacitors, and I'm going to do this all in MLCC, multi-layer ceramic capacitors, because you can get 10 microfarads in those. Let's see if I can find some basic parts for this. These are all extended. Okay, let's go to the second one. I'm not sure entirely what the difference is, but let's see if there are some basic ones in here. And yes, we have a basic part, 100N. So let's see if I can find the big one first, the 10 microfarads, 4.7, 10N, 470N. So I'm looking just for a 10 microfarad MLCC. I'll come back when I find it. So I found this one. It's a basic part. It's a Samsung, 10 microfarads. It's an 0805, which is a sensible size. So even if I have to rework it, I can probably get to it. So let's have that one. I'll place that. Don't want a second one of those. Now I want 100N on the input. So let's carry on the 100s and see if I can find 100N. Here they all are. Basic Samsung 080. Oh, that's where's 0805? Chemet. Well, let's stick to Samsung, but now I'm struggling to find an 0805. I'll come back when I find one. Right, found this one. C0805 100NF. Oh, that's an extended part. But anyway, it's a Samsung. I'm going to have it because it matches the other one. They'll probably be anonymous anyway and have no markings on them. But anyway, let's have one of those. And now I'm going to put two more capacitors, one on the in and one on the out. I'm going to go for 10 ends. So let's see if I can find 10 ends. 0805. Oh, Johansson dielectrics. That's interesting. What else have we got? Once again, I'll have a look through this. Right, I've got a C0805 10N basic part, Samsung. So we'll have a couple of those on my drawing, C3 and C4. Right, I think that's probably good enough. Let's bring these up because I think they're hidden behind my image. So I'll place these in. Now, which one do you have closest to the regulator? I guess the small one, because that will be taking out the high frequencies. So you want that as close to the regulator as possible, and the big one perhaps further away. I don't know. I'm working on the schematic. It's irrelevant pretty much at the moment. So let's have the 10 mic is the big one, isn't it? So that goes on the output. I'm going to have to rotate these. Let's place that there. I'll put a 10N next to it. Let's do C3. Rotate that. I'll put the other 10N on, rotate that and put it on the input. And the 100N, rotate that and put that on the input. Okay, I'll move those up, make them a bit neater, and then we'll start linking them up. Okay, I'm going to zoom in, so I'm just rolling the mouse wheel. Let's get it nice and big. Right click and drag to move it where I want it. Right, let's pick a wiring tool. I will wire the input down to this capacitor and this capacitor. The output down to the 10N and the 10 microfarad. I need a ground, which I can put there, and then everything links to ground. So let's link ground on the regulator to ground, and then come out to the 10N, come out, oops, slipped a bit there, sort that out in a minute, do the 10N on the input and the 100N on the input. Can I fix this? Yes, I can drag that to there and link that to there. The tab, I suppose, should be connected to pin 2, which is the center pin. V out is the tab and the center pin. So that's really the power supply section. Pretty straightforward. I think I'll now find an LED and a resistor and add those into this schematic. Well, I can't work out. I've put this in sequence of part class. So these are the basic parts. There's no point having an extended part. I just want an 0805 red LED. This one is green. This 0805 is white by all accounts. There's an 0805 here. It's an XL 0805 QBC, but it doesn't say what color it is anywhere, even in the datasheet. And that's all of the basic 0805s. So that's interesting. Perhaps I'll just pick that one and have it green. I mean, I kind of wanted it red, but this one will do. We'll have that, and now I need a resistor. So let's go to resistors. I want a 1K. They're going to be thousands of these, aren't there? Resistors. Come on, computer, you can do it. Oh, carbon film resistors, chip resistors, surface mount. That's what I want. And I'll go for the basic parts again. So part class basic part 0805s. And I want a 1K. Well, there should be one in here somewhere. Let's scroll through until I find it. So I've got my LED. I've gone for this one. I don't even know whether this is red. I'm hoping it will be. But there you go. Let's rotate that so it's facing downwards. And I'll put the 1K resistor in there. Can we do a Y on that? Yeah, that just moves the name. Just see if you can see all this. Yes, you can. That's good. Okay, let's wire that up to the output, like so. That to there, and that to ground. Good. So we've got an LED, a 1K resistor on the output, and we need to now feed these two connectors and also connect up the input connector. Well, actually the input connector is pretty straightforward, so let's do that. I don't know about my 1s and 2s, it doesn't really matter. So that goes to V in, we'll have 1 go to ground. That should be fine. Might rename this actually to input, because HDR, whatever it said before, doesn't really mean a lot. Let's come to the output. So now it's a case of simply feeding power through to the 8-pin connector to the NRF transceiver, and also working out the arrangement of pins on this 5-pin connector and how they link through to this 8-pin connector. So looking at this, on the 8-pin connector, we've got ground and VCC next to each other, hence the capacitor. That appears to be marked as pin 1 with that square, and that appears to be ground. And that's fine because I think I put pin 1 as ground on my power connector as well. So pin 1 on the 8-way connector to ground, pin 2, which is opposite it, is VCC. Let's go back to EasyEDA. Right, so I think I'll rename this as just NRF, keep it nice and simple. That also means I can route pin 1 to ground, which can come round like this and up to there. VCC, I suppose I can come off that point, can't I? Can come up, let's take it up there, and that goes to pin 2. So those are done, that's good. Right, now let's deal with the signals that go from my 5-pin connector down here. This is a 6-pin, but we can ignore the 6th pin because it's not used. So let's say that this is pin 1, that's D13 on the Arduino. That runs up to the 3rd pin there, which is S clock. So pin 1, D13, goes to S clock. So we need to connect pin 1 here. I'm going to run out of space, aren't I? And that goes to pin 5. Now the name of this is, well, it's D13 on the Arduino and it's S clock here. So I think I'll put in a name. I think that's a naming thing. A net label. And I will make that D13 slash, if you can have a slash, SCK. Let's see if it allows that, and we'll progress in that manner. So once again, looking at this, the next pin, pin 2, D12, that runs up to the last pin on here, not including IRQ, which we're not going to use, and that's MI, so that's MISO. D12 MISO from pin 2. It looks to me like this is probably going to be better dragged down here. Let's put it there for the moment and continue. So pin 2 here will be D12 on the Arduino. Let's find out where that goes. So on here, D12 MISO. Did I actually see where that went on the connector? Not really. That's pin 7, so that's relatively easy. That's here, 2 to 7, and the name for that one will be D12. Put a 2 in there and call the last bit MISO. 3 more to go. Okay, D13, 12, so D11 is the 3rd one in. That runs up there to the 3rd one back from this side. That's Mozzie, and Mozzie is around the back here. MO, pin 6. So pin 3 to pin 6, D11 Mozzie. So that's pin 3 to pin, let's come out a couple, pin 6, and the name will be D11 and MOSI. So all looking good so far. Pin 4 here will be 13, 12, 11, 10. 10 I believe is, I think it's CSN. Let's have a look. Back to this, 13, 12, 11, 10. So pin 10, 4th one from this end, there. Oh, where does that go? Oh, that goes up to that one, which is one from this end. Yeah, 10 is CSN, and CSN on this connector, can't see it with that in, is that pin, and that's pin 4. So it's actually my pin 4 on here, and it's D10 CSN. Okay. So on here, it is pin 4, to pin 4, and the name is, I'm going to run out of space, but never mind, D10 and CSN. And D9CE. Well, we can't go wrong with that, can we? Better check it though. And it'll be this 5th one along here that runs up to this end pin, which is CE. So D9 is CE, and CE is there on pin 1, 2, 3. So it's the 5th pin along here, 5 to 3, D9 CE. On here it is 5 on my connector to 3 on the 8-pin connector, and the name, which I might just have space for if it'll allow it in there, is, oh, why have I put D110? That's no good. Well, let's change that one for a start. So D10, and this one is D9, and it's CE. Good, that's it. Now this is unused, pin 8 on the 8-way connector, and I would assume that's IRQ. And here it is, pin 8 on the 8-way connector, and that is indeed IRQ. We don't use that. It is broken out on this board, it's there, but I have nothing connected to it, and I don't use pin 8 on my connector. So that's it, that's done. Just one more thing I wanted to do on here. This connector H1, I think I'll just name it Arduino. D13 to D9. I just call it Arduino, I think. Oh, that's shot over there for some reason. So I think that'll do for now. The next thing we've got to do is convert to a PCB. I'll just check in the edit how long this video has got so far. Might make that a second video, might carry on. And I've just plugged the tower back into my Arduino breakout because I wanted to see what the temperature in the shed is. 25 degrees, that's fine. It's not 25 degrees outside, but the shed's quite warm because my miners are running. Because at the moment I'm running them pretty much all the time because they're profitable. Oh wow, 30 minutes of schematic design, so I'll leave it there. We'll come back and in the next video make a PCB and send it off for manufacture. Cheerio.